Greetings of the day. My name is Tomin Joseph and I am from the Department of Computer Science PG, Kristu Jayanti College. Today my lecture is on data structures and algorithms, and in particular we are going to deal with a data structure named linked list. Now fundamentally, when we think of representation of data in computer systems, we have to think of data structure. So data structure is a mechanism to store and process information or data, and in particular when we think of data structures, the data structure that comes into the mind of students is arrays, and arrays is a very simple way of representing data. There are no frills attached to it. It goes in a sequential order and the information is stored in a sequential way, and we will be able to access information based on the index that is provided in the array. So it's an easy mechanism. It's a mechanism that is known to us, and it's a very structured form of representing information. Now at all times we will not be able to use or we can use arrays, but the complexity would increase based on the problem, because an array to a large extent can only store one type of data. That means it cannot store information in multiple forms. For example, if I take a particular student, the student has additional information or metadata as we call it, student ID, name, address, phone number. Okay, I want all this information to be stored as a single unit or a node. So for that particular reason, if I look at array, an array would find it a little difficult to store that information. So we have an array that is powerful, popular, and at the same time it works with the heart of a computer to a large extent, and that would be nothing else other than linked list. So a linked list fundamentally in computer science is used for organizing and storing a collection of elements referred to as nodes. So the what differentiates an array from a linked list to a large extent is that an array requires contiguous memory allocations in the computer system, which primarily means that if I am going to store information, I need to tell the computer, you allocate this much amount of space for me, and based on that the allocation of data would happen. But in linked list it's a lot more free, in the sense that the allocation would rather happen dynamically, which means that as I add more nodes or as I add more student information in the problem that I was speaking about, the number of nodes would increase and the memory is allocated dynamically. This has a lot of advantages. For example, in arrays it's a fixed size, and even if I don't use a certain amount of memory, that memory would be wasted. Whereas when it comes to linked list, a linked list will only take that part of the computer memory that is very much required for my processing. So a linked list is very powerful in that sense. But because it's dynamic memory allocation and you're working with the memory part of a computer system, it's very important to recognize here that when I allocate memory, it's the duty of the programmer to a large extent to even perform deallocation of memory, because a computer system literally goes and searches for memory, and you permanently store in that particular memory allocated, and that makes linked list powerful. And at the same time we have to be extremely careful on how we perform operations on linked list. Okay, so again because it's dynamically allocated, addition and deletion of data would be increasingly easy, but at the same time complexities are involved. Okay, so this is a general representation of a linked list, and as you can see, a unit of a linked list is something that we call as a node, and a node has exactly two parts. A node has the data part and the address part, which points to the next node in the linked list. So when I think of a linked list, now the biggest problem when we think of a linked list is that these nodes are connected, because the address part of the node contains the information about where the next node in the linked list lies. But the most important information here is how do I point to the first node in the linked list, and that is done by the head pointer, because the head pointer is, please don't consider it to be another node, but the head pointer to a large extent has the address of the first node in the linked list, and the first node will help us traverse across the linked list. Okay, and this is the most simplest linked list representation that we can think of. So like I said, node in a linked list has the data part as well as the address part of the next node, and the last node in particular will point to a null value, because that would be the end of the linked list. So if we can understand how a linked list is represented, it's much more easy and much more efficient for us to process the nodes in the linked list. So when I think of the head part, now when I have to traverse the linked list, the first thing I would do is that I would traverse to the first node in the linked list. The first node in the linked list, the information is given to be by the head, and the how to stop processing the linked list. I would process the linked list till I reach the null value. So that would be the end of my linked list. So this is one easy way of traversing through linked list. So what is the most fundamental block of a linked list? The most fundamental block of a linked list is a node. So when you think of a node, it contains, like I said, we are going to repeat this over and over because this is the most important unit of a linked list. It has the data part as well as the address part of the next node in the linked list. And what makes linked list so powerful is that these nodes that we have here in this particular diagram, the data part is not necessary that it has to be integer or character or floating point, okay, or string. It's not necessary that it has to be of a single data type. It can be to a large extent a combination of various data type. Okay, that is our node, and that is why a node is so powerful. So if you think of a class, if you think of one particular student, there is multiple information I can store in the node, and if my head node points to the first roll number in the class, then I can easily traverse through the class till the very last roll number, and I'll be able to access the entire student record that way. So a linked list in particular is very, very powerful in representing information. So what we saw in this diagram, this is what we call as a singly linked list. Why do we call it a singly linked list? So basically you can traverse in the forward direction, and each node will only point to the next node in the linked list. Okay, that is what we call as a singly linked list representation. Then we have what is known as a doubly linked list representation. In doubly linked list representation, you can move forward and you can move backward at the same time. So along with the data part, you have two additional parts stored in a doubly linked list. And finally, there is what we call as a circularly linked list, in which the last node in the linked list points to the first node in the linked list. So why do we have these different types of linked list? This helps us traverse in various directions. So singly linked list helps us move from the first node to the last node. A doubly linked list helps us move forward as well as backward. So if you require traversals in both directions, this would be helpful. And a circularly is very important, because here you need to remember that there would be no wastage of memory, because a circularly linked list helps us point from the last node to the first node. Thank you.